Algebra 1 9.2 notes. So we are solving quadratic equations by graphing. All right, so when we talk about a quadratic equation, which we've talked about a lot of times, it's a nonlinear equation, and it's in the standard form ax squared plus bx plus c. And so we solved these by factoring in the last chapter, but we can also solve them by graphing. So here are the steps to solve by graphing. So step 1 is write it in standard form. So it goes ax squared plus bx plus c, but it must be equal to 0. That's what you do before graphing is. It must be equal to 0. Then you graph that function and you find the x-intercepts. So these are the solutions or the roots. They are the same as where the x-intercepts are on the graph. All right, so take this equation right here. It is not equal to 0 yet, so we need to subtract 3. All right, so when we do that, we get x squared plus 2x minus 3 equals 0. All right, so must be equal to 0 first, and then we can graph. So if we look at this one is in standard form. We have lots of different ways to graph. One of the ways we have to graph is when it's in standard form, we can use negative b over 2a to find the vertex. So if I do that, I have negative b is 2 over 2, a is 1. All right, that gets me negative 2 over 2, which is negative 1. Remember that that is the x value of your vertex, the first part of the point of your vertex. So if you have negative 1, then you plug it back into that equation. Remember that you use a calculator and use parentheses. So this is what I would type into my equation. This is me plugging in negative 1. I would just type this into my calculator. So I plug that into my calculator. I end up with negative 4. So the vertex is at negative 1, negative 4. All right, and then normally we graph enough points. We graph 2 points on each side, but in this case, we need to graph enough points so that it does actually cross the x-axis. So if I plug in 0, I get negative 3, and if I plug in 1, I get 0. So 0, negative 3, 1, 0. Remember, we did this back in the previous chapter. And then remember how you can draw on your axis of symmetry and just reflect your points over. All right, so this is your graph. And where the solutions to your graph are, the solutions to your graph are the x-intercepts. So right here, x equals 1. And right here, x equals negative 3. Those are your two solutions. Okay, so let's go ahead and try the next one. So once again, we can go ahead and we can move the 16 back over. All right, so I get x squared minus 8x plus 16 equals 0. All right, so there's many different ways to graph. Okay, we could go ahead and we can find the vertex using negative b over 2a because it's in standard form. You could also factor this, and if you factor it, you get it into intercept form. So, for example, if you want to factor this instead, what multiplies to 16 and adds to negative 8 is negative 4 and negative 4. I see that this is the easier kind of factoring because the a value is 1. So it's not bad to factor it. That's just an alternate way. We wrote now in intercept form. So now we know that our intercept, you set them each equal to 0. Since they are the same, they repeat each other. So we get x equals 4. So that's just an alternate way, okay? The negative b over 2a still works perfectly fine. I just was reviewing several different ways that we had done it previously. We had graphed by writing in intercept form, we had been in vertex form, and we had done standard form. All right, so the the intercept is at 4. There's only the one intercept. So when that happens, that tells me, oh, this must be a vertex. So let's just double check. If we plug in 5 and if we plug in 6, then what I'm going to get when I plug in 5 is 1, and when I plug in 6, I get 4. So let's see what that looks like. And so that does confirm what I was thinking, was that since the x-intercept, there was only 1, that tells me, oh, hey, that also happens to be the vertex. So this graph only has one solution, and its solution is at 4. So the previous graph had two solutions because it had two x-intercepts. This graph only has one solution because it has one x-intercept. So either way can happen. All right, now let's look at this one. Okay, so we can go ahead and we can move everything towards the left, or we can move the x squared back towards the right. Okay, it technically will work either way. It doesn't actually matter. So I'm going to, just because I only have to move one thing, I'm going to add the x squared over. So I get 0 equals x squared plus 2x plus 4. Okay, so we could try to factor that, or we could do negative b over 2a. Both are great methods. So negative 2 over 2 times 1 ends up being negative 1. So our vertex starts with negative 1. Now I'm going to plug negative 1 back in. So using a calculator, what I'm typing in my calculator is this. So I end up with 3. So negative 1, 3. And so then I'm going to make some more points. And I have at 0, I have 4. At 1, I have 7. Okay, so if we reflect those over, this graph never crosses the x-axis. If you look at it, it has no x-intercepts. So when that happens, what we put is that there are no real solutions. There are imaginary solutions, which you learn about in Algebra 2. So we can't just put no solutions, we put no real solutions. So basically you have three options. You can have no real solutions when there's no x-intercepts. When the vertex is on the x-axis, you have one solution. And when it has two x-intercepts, you have two solutions. And that's all the possible answers you can have when you're graphing a quadratic. Okay, these are examples of a graph that is like this one on A is not quadratic. This is called a cubic function. We don't have to know how to graph these, but just to point out, when it says find the zeros, okay, or find the solutions, it wants us to find the three x-intercepts. So the first one is at negative 1, the second one is at about 2, and the third one is at 3. So this is an example that has three answers, but keep in mind, this is a cubic function. This is not a quadratic function. And so that's why this one has three answers. But you can just look at the graph and find the x-intercepts. All right, this equation says a football player is kicking a football 2 feet above the ground. The initial vertical velocity is 75 feet per second, and it gives us this equation right here. So h is how high the football is after t seconds. So if we plug in 0, at 0 seconds, it's 2 feet off the ground. Then let's plug in 1, 2, 3, 4, 5, so on. Let's just make a table. So we can plug these numbers in each time, or we can pull up a table. Either method works fine. But these are the y values I get when I plug them in. So it says estimate when the height of the football is 50 feet. Well, I know that between 83 feet and 46 feet, it must cross 50 feet. And I know it's probably going to be closer to 46 than it is to 83. So it's closer to 4 seconds. So I think it's just before 4 seconds. So like maybe 3.9 seconds. I'm just guessing here. And then I also know somewhere between 2 and 61, it has to cross 50 foot. Now, it's definitely closer to the 61, so closer to 1 second. So I also think that it is just before 1 second. I'm guessing like 0.8 or 0.9, I don't really know. Let's put 0.8 seconds. A little bit less close to the 61 than the 46 was. So, and the reason I know it crosses 50 feet there is because if it goes from 2 to 61, then it has to cross 50 feet. Okay, so they said on part C to go ahead and use a graph and find out when this works. So what I'm going to do is I'm going to type in the equation right here first. So I'm going to use a graphing calculator, and I'm going to type in negative 16 x squared, and then we have plus 75x, and then plus 2. All right, and then on the second equation, I'm going to go ahead and type y equals 50. Okay, So when I'm looking at this window, keep in mind, if I look at the table that I had just made, I know my x's go from 0 to 5. So I'm going to change that. I pressed window and I'm going x min is 0, x max is 5. The y min I'm going to put as 0. And then it went up to 88. Let's give it a little room. Let's leave it at 100. Let's go up to y max of 100. And I'm using the numbers off my table to determine that. So here's the path of my football, and then this line across is at 50 feet. So I want to know these two parts where they intersect. So what I'm going to do is I'm going to see where it says calc above trace, hit second, and then trace, and then 5 is intersect. So go down to 5 and hit enter. And it says first curve, hit enter, second curve, hit enter, guess, hit enter. So the second one, you see it tells me is 3.9. Let's do it again. Second, trace, because it gets you to the calc screen, go down to intersect. Now this time you have to scoot the cursor, the flashing part, closer to the other intersection so it knows you want it to find that one. So just somewhere closer to it and hit enter, enter, enter. And this was 0.76. So I would say my answers are about 0.76 seconds, and it was close to 3.9 seconds. So we did pretty good, honestly. So remember that we graph equation for y1 and y2 we graph 50, and then we do second, and we do the trace button. I put these in buttons so you can see that. On 5, which is intersection. Okay, and this is also a calculator one. There's a table showing all of this information. And so it says, use technology to find a quadratic model. We've done this with other things, so let's see what we do. We are going to see if I can make it smaller so we can see our table. Okay, we're going to go to stat, and we're going to hit enter on edit. We've done this a lot. I'm going to clear out my list. I'm going to go up to L2 and hit clear, enter. And I move my cursor up to where it's on L1, and I'm going to hit clear and enter. Okay, I'm typing in my data, so I'm typing in 6, 8, 10, 12. All right, this is going to be weird. I'll show you what I'm doing here. I am typing in 14 because at 2 p.m. it's 14 hours after the start of the day, and then 16 is the 4, and 18 is the 6. All right, type these in, 58, 68, 76, 82, 84, 81, 75. All right, and so when it wants us to use technology to find a quadratic model, we do stat, go over to calc. We've done this a bunch, but this time we want the 5th one, which says quadratic regression. So we want to go down to 5, and then list 1, list 2, calculate. Okay, so our A value is negative 0.43. B value is 11.7. C value is 2.2. Okay, so we had said my A value was negative 0.43, so that's what goes in front of x squared. We said my B value was 11.73, that's in front of x, and my C was like 2.2. So that's my equation. And then if you look at this r squared value right here is 0.993. The closer that is to 1, the better. So this is very close to 1.99. It's really close to 1. And so that means that it's a great fit. So because r squared is 0.993 and is close to 1, it is a good fit. All right, one wants to know what times that the temperature is 77 degrees Fahrenheit. We can go ahead and we can graph just like we did last time. We can graph this as y1 and as y2 77 and find the intersection. All right, I'm just going to show you this real quick. I typed in this for y1, the second equation for y2. When I went to graph, I was too zoomed out. I changed my window to go to 0 to 24 because of 24 hours in a day. I left it going up to 100. When I press graph, I see it intersects twice. So I do second, the trace button, because it gets me to calculate and intersect. And so the first is at 10.2, which is like at 10 hours.